Dear students, I welcome you all to this physics tutorial series. I am following the book by NCERT for class 11. So in this video, we will solve the problem number 3.15 from the chapter number 3. In this problem, we are given that in exercises 3.13 and 3.14, these are the two previous problems we have already solved. We have carefully distinguished between average speed and the magnitude of average velocity. No such distinction is necessary when we consider instantaneous speed and magnitude of velocity. The instantaneous speed is always equal to the magnitude of instantaneous velocity. Now we are asked to explain why. Okay, so first of all, let us understand what is speed and what is velocity. So we know that speed is equal to total path length divided by the total time. Here path length means the total distance traveled, the distance of the path it has covered divided by the total time or the time interval we are considering. We are calculating the speed in meter per second. Then in 1 second of time, how much meter distance is traveled, how much path length is covered. So in the case of velocity, what we have, total displacement divided by the time interval. These are the two definitions of average speed and average velocity. Here we can write this is average speed and this one is average velocity. So we are considering the total path length in the case of speed and we are considering the displacement in the case of velocity. So what is the difference? Difference is that the path length and the displacement. So what is the path length? Suppose we have a straight line like this. So suppose a object is moving from here. First suppose it goes to this point. Okay, then it again goes to this point and then it comes back to this point. That means suppose this one point is B, this point is C. So what will be the path length in this case? So path length will be the total distance traveled. Therefore it will be AB plus BC plus CB. Okay, so this is the total path length object has traveled. But what about the displacement? We will have, this is nothing but this one. Let me show you with another color. This one is the initial position, this is the final position. So what will be the displacement? We will find out the final position distance from the initial position and this is equal to AB. Okay, so here in this case we can see that the path length is this much, AB plus BC plus CB, and the displacement is AB. So both these two are different in the case of rectilinear motion also. So we have already discussed this concept in our previous two problems 3.13 and 3.14. Now when the path length and the displacement will be different, average velocity and average speed also will be different. Now in the question we are given that instantaneous speed and instantaneous velocity is always same. Why, we are asked. Now let us consider. So instantaneous speed, when the time interval delta t tends to 0. Okay, so let me write down here limit delta t tends to 0. So this will be the path length divided by the time interval delta t. Okay, time interval means suppose t2 minus t1, we can consider to be delta t is equal to t2 minus t1. Final time minus initial time, this is the time interval. When the time interval tends to 0, that means the time interval is infinitesimally small. When the time interval is near to 0, then the path length traveled is the instantaneous speed. That is path length divided by the time interval or the infinitesimally small time interval. It is called as the instantaneous speed. Similarly for instantaneous velocity also, similar definition we can write. In the case of instantaneous velocity also, limit delta t tends to 0 and here we'll have the displacement. Suppose the time interval is delta t. Here also when this delta t tends to 0, displacement also will be very small. So in this case the path length and the displacement will be equal. So when delta t tends to 0, that is delta t is very small quantity, then path length will be equal to the displacement. So you have to understand this point. When the time interval is very small or tends to 0, then the path length will be the displacement equal to the displacement. So we can say that the instantaneous velocity is equal to the instantaneous speed. So here we can write instantaneous speed is equal to instantaneous velocity. So this is the solution of the problem number 3.15 from the chapter number 3. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.